Hello data managers, this is Mr. Dunbar speaking, and today I'm going to go through Activity 5 in Unit 5, and we're going to take a look at how we solve probability problems using basic counting principles. So there's an introductory video that's already on here, and what we are going to do now is take a look at some of the questions that were provided to us. Here's our first example. We roll a die 60 times. How often should we expect a 4 there in theory? Well, we should expect 10 of them. 60 rolls, we should expect 10 rolls to show up with a 4. 1/6 of the time we should see 4 on the top face of the die. This reminds us of grade 9 math, I imagine. So let's look at a second example. If we're tossing 2 coins, what is the probability that they'll both turn up heads? Well, there are 3 solutions I'm going to show you. The first one is where you're going to list all the outcomes. So we can list heads heads, heads tails, tails heads, and tails tail. So when we look at it, we see there are 4 possible outcomes. And by the way, one term that you should note here, the total number of outcomes is called the sample space. Now let's look at the second solution. In this case, we're using a tree diagram. So we're quite familiar with tree diagrams with nodes by now and branches. So the event that we're interested in was where we had 2 heads. And the way to read this tree diagram is to look at the first branch. So we've got either a head or a tail for the first coin, and then we have a head or a tail for the second coin. So we're looking for a tree diagram, an event where we've got a head followed by a head. So in this case, again, we have 4 different outcomes, 4 different nodes at the bottom, and we have to go down our tree and follow a particular path, a particular branch to get the outcome, the heads in this case. And then the final solution, the third solution, is one where we use the product rule. So again, I want to highlight the use of the term sample space, and I also would like to point out how we write the event that we're interested in. So NA, so a number of ways that event A can occur, and N bracket S represents the total number of outcomes in that sample space. And just let's take a look at the question that we looked at a moment ago. So again, here we have capital P bracket A bracket. That's the probability that event A occurs. And the probability that event A occurs is equal to the number of ways that A can occur divided by the total number of ways that you can have in the sample set. So the total number of outcomes in the sample set. So P of A is equal to the number of events, the number of ways that event A can occur, divided by the total number of outcomes in that sample set. Let's change the question slightly. We have 5,005 outcomes in a sample space. What is the maximum possible value of N bracket A bracket? So the number of ways event A can occur. Well, let's use our formula. The probability of A, the probability of event A happening, is equal to the number of ways that event A can happen divided by the total number of outcomes for that particular sample space. In this case, all 5,005 of these outcomes could be event A. So 5,005 divided by 5,005 is equal to 1. So in this case, our probability, the maximum probability, should be 1. Or another way of thinking about it is 100% all the time. So I want you to take a look at what I highlighted here in the rectangle. So probabilities have to be between 0 and 1. We translate that into 0% to 100%. So a way of writing it would be, therefore, the 3 little dots, 0 is less than or equal the probability that event A occurs, which is less than or equal to 1. or 0% is less than or equal to the probability of A is less than or equal to 100%. Typically we talk about 0 to 1 when we talk probability. 0, by the way, is an impossible event. 100% would be a certain event. So, what is the probability we will draw an ace out of a deck of cards of 52? Well, ace can be one of the 4 suits: hearts, clovers, clubs, diamonds. So what's the probability of drawing an ace? Well, we have 4 aces that we can choose from, and our deck is usually 52 cards large. So we can simplify 4/52, 4 over 52, to 1/13. In this case, we got 4 aces in a deck out of 52 cards. There are 4 ways for our event to occur, and we've got 52 possible outcomes in the sample space. So we could change this to a decimal, and our decimal answer would be 0.077, or 7.7%. So here's another deck of cards question. What's the probability that we do not draw a face card out of a deck of cards? Well, we can figure out that probability in 2 ways, directly and indirectly. So indirect reasoning and direct reasoning. Now the answer is 40 out of 52. There are 40 non-face cards in a deck. Well, we can figure that out by counting the number of cards that are face cards. So we know that's Jack, King, Queen, and multiplying that by the number of suits, which is 4. So 3 times 4 is 12, and in that case you got 52 minus 12, and you got 40 non-face cards. Or you could do it the other way around and go ace 2, 3, 4, 5, 6, 7, 8, 9, 10, and then multiply that by 4 to give you 40. Either way, you're trying to figure out the number of ways that event A can occur, and event A is the drawing of a non-face card. So 40 out of 52 simplifies to 10 out of 13. So let's look at some of the terminology that goes with this. So we can apply indirect reasoning, the complement method, and we also need to know a little bit about how to write that. So if we have A as our event that we're interested in, and then we have a complement, and the way we would write it is A prime, A with this little apostrophe. So the probability of the face prime, that would mean the probability of not drawing a face card, is the complement to the probability of drawing that face card. So we're looking to find out what all of the events are and subtract the events that we don't want. So the events we don't want are drawing a face card. Now the text gives you a faulty answer. I'm not going to go through that faulty answer. We're going to go straight to the correct answer. The probability of drawing face prime is equal to all probabilities and subtracting the probability of drawing a face card. So in this case, all probabilities would be 1. Subtract 12 over 52, that's the probability of drawing a face card. So 52 over 52, subtract 12 over 52 gives us 40 over 52, not shown here, and that simplifies to 10/13. So one pretty good principle to keep in mind is that the probability that something will happen and the probability that something won't happen, so P of A and P of A prime, they should always add up to 1 if they're mutually exclusive events. So P bracket A bracket plus P bracket A prime bracket equals 1. Now, this allows us to do some neat things like rearranging the formula. This allows us to make a statement like the probability of A is going to equal 1 subtract the probability of A prime. So the probability something will occur is equal to 1 subtract the probability that it won't occur. By the way, this is in mutually exclusive events. So The probability that it's going to snow tomorrow is 70%. The probability that it won't snow is 30%. So in this case, you'll notice that 1 subtract 0.7 equals 0.3. And the other way of looking at it is as a percent. 100 subtract 70 is 30. Now, I'm going to stop recording the video here. Do take a moment to look at the rest of the questions. And please post any questions that you have in the Student Discussion Lounge.